here is your Unit 7 quiz review. So first two are differential equations. For the first one, to separate, we're going to multiply over the y to the fourth, and then we're going to multiply over the dx. And then we're going to do our antiderivatives. So for the left side, it's 1/5 y to the fifth. Over here, it's going to be negative cosine of x and then plus c. There's not an initial condition, so we're going to skip that step. We're going to just get y by itself. So first thing, to get rid of the 1/5, we're going to multiply everything by 5. And then to get rid of the fifth power, we're going to do a fifth root. And I don't need to put a plus and minus because that is an odd root. But if it was an even root, so a square root, fourth root, sixth root, eighth root, you would just put a plus minus in front. For this one, we're going to divide over the y squared, which when I move it to the other side, it's going to become y to the negative second. It would look like this, but I'm just writing it with the negative exponent. And then I'm going to multiply the dx over. So still on that side, we have 4x dx, antiderivatives. I'm going to add 1 to this power. That's going to make it -1. And then I would need a -1 in front of that. So it would look like this. But I'm going to write it with the y in the denominator so that I don't have a negative exponent. On this side, it'll be 2x squared plus c. This one does have an initial condition. We're going to plug in -1 for x and +1 for y. So if I put a +1 here, that's going to be -1. Over here, -1 squared is +1 times 2 will be 2. And so c is -3. I'm going to recopy this line exactly like it looks, but instead of plus c, I'm going to put -3. Now, mathematically, what's going to happen next is this y is going to get multiplied over to this side, and then all of this is going to get divided over to the other side. So essentially, those two things are just going to trade places. And so it's going to be -1 over all of this equals y. This is a general solution. It's an infinite number of answers because c can be anything. This is a particular solution because we found what c is specifically for this initial condition. So this is one answer and this is infinite answers. All right, here we're going to do a slope field at the points that are shown. So let's do our zero slopes first. If x is 0, this whole thing is just going to end up being 0. So everywhere x is 0, I'm going to put a 0 slope. And everywhere y is 2, I'm also going to have a 0 slope. 2 minus 2 is going to give us 0. So here and here. And then we're going to need to kind of trudge through filling in the rest of this. So let's start here. This is the point 1, 3. So if x is 1, that's just going to be 1. 3 minus 2 is 1. So slope of 1. All right, over here we have -1, 3. It's actually going to end up being the exact same thing, though, because -1 to the fourth is just going to be 1, and then that'll also just be 1. So actually, same thing. That wasn't too bad. Here we have 1, 1. So 1 to the fourth is just going to be 1. 1 minus 2 is -1. And then the same thing is actually going to happen over there. So actually, this isn't too bad. Usually there is some symmetry or, some that you can copy over. So you don't have to do them all one at a time. All right, and then 1, 0. So again, x is 1. This part's just going to be 1. 0 minus 2 is -2. So I just need that to be more steeply negative. And the exact same thing is going to happen here because -1 to the fourth is just going to be +1, and it'll just turn out the same. All right, use that slope field. This is all part of the same problem. To explain why a solution could not look like this. Well, this one has a horizontal asymptote at 0, but the horizontal asymptote should actually be at 2. And so we just need to say something like that. So horizontal, you can abbreviate, asymptote should be at y equals 2, not y equals 0. So however you want to say something like that in your own words, just why this doesn't match that slope field. All right, over here we have matching. The way this is on your quiz, I just put these on here so that this is like more examples than what is on your quiz, is you're going to have a slope field and then like your choices A, B, C, D will describe it and I'll just pick the right one. But if you can match all these together, then you'll know what's going on. All right, so y equals 1 is going to be this one right here, so D. You can think of that like, y equals 1, it's just a flat line at 1. But if you did a derivative, the derivative of just a constant is 0, so you're just going to have these 0 slopes everywhere. I don't need to necessarily do these in order. I think I'm going to look for like the easiest ones first. Y equals x is going to be, where did it go? I just saw it. This one right here. So if you draw in y equals x, that's just a line with a slope of 1. So h is going to be this one. Sine of x, sine starts at the origin. So that one is going to be E. If you look right here, start at the origin, that's where our wave goes in. So that one's E. And I think there was a cosine. Yeah, cosine is going to start at 1. So this one is our cosine wave, is B. Let me find x squared. That should look like a parabola. So let me see. I see that. Nope, C right here. So if I were to draw in a parabola, that's going to be that one. This is a cubic, so that's going to be F, this one right here, if you draw in. And ln is going to be this one right here. So your ln has this vertical asymptote at 0 and then kind of like a sideways swoop. And then, which was the one I skipped? 1 over x squared. So it is a rational graph where both your sides look like this. So A for that one. So there'll be things like for this differential equation, the solutions are increasing or the solutions are decreasing. Or they have a horizontal asymptote or something like that. So if you like sketch a slope field real quick, you can look at it. So like, for example, you could look at this cubic one. This is always increasing, for example. So if you can match these together, you'll be able to read through all the choices and pick